Chapter 3, number 38. The blue curves shown in the figure display the constant speed motion of two different particles in the xy plane. For each of the 8 vectors in the figure, state whether that vector is a position vector, a velocity vector, or an acceleration vector, and I guess explain why. So we look here and we say that we have the particle traveling, for instance, along here, or a particle traveling around like that. So if we look, location or vector 1 points to the curve. So position 1 or vector 1 is a position vector. It points from the origin to where the particle actually is. And we can see that actually number 5 is going to be the same thing. So 5 is also a position vector, because in both cases the vector points from the origin to the location. If we look at vector 2 points tangent to the curve. So the guy had been here and then moved to the other blue dot, and we know that the velocity vector is always tangent to the curve. So 2 is a velocity vector. And looking over on the other side, the other vector, we see that, 7 is also a velocity vector. It's tangent to the curve. And so is 8. So we're basically halfway done, accidentally on the way. And then it kind of looks like 3, harder to tell, but it kind of looks like 3 is also a tangent. So 3 is also a velocity vector. And that sort of logically leaves us with only one possibility for the other guys, but we should probably talk about them. The acceleration is what causes the path to turn. Right? It's what causes the change in direction. It's what turns the tangent, right? Because the acceleration is the rate of change of the velocity. So it's why the path is not a straight line path. And so it's got to sort of, if you think about the acceleration always is sort of in the direction of a pull, we are pulling this particle so that its velocity, for instance, here goes a little bit to the side. We've pulled it this way. 4 is an acceleration. And then for exactly the same sort of reason, if you imagine that the particle is doing this, it's being pulled this way, and 6 is also an acceleration. So our shortcut kind of thing is, if we point to the curve, it's a position vector. If we are tangent to the curve, it's a velocity vector. And if it's sort of off the curve, then it probably has to be an acceleration vector. We have to be a little careful because the acceleration vector could point along the tangent as well, if it were simply speeding up, if it were not turning at that point. But definitely things that point off the curve have to be accelerations.